ARA and the U.S. Army Engineer Research and Development Center, along with other research partners, have successfully created a time, resource, logistics, and cost-saving expeditionary construction system. It's called ACME Tech. That's an acronym for Additive Construction of Maneuver-Enabling Technology. It's 3D printing concrete, but the best part, this innovation eliminates the need to transport far more than half of the traditional ingredients for building concrete battlefield items by using local, indigenous soils anywhere in the world.
So instead of having to take a different size culvert for every mission, or to take a different culvert in a T-wall or a Jersey barrier that takes up a lot of logistical footprint, they can just take the raw material, cement, and they can combine that with a local material, indigenous soil that they find near the point of need.
We've got a small processing operation that we do that's compact track loader, CTL sized equipment, attachments. One of them's a screen. We have a small crusher that we use to process the material, make it a little bit more ideal to print. We're able to generate enough material to print today, so we can keep up with our processing operation with what the printer's outputting. It's not an issue on the job site.
We had Saudi Arabia sand that we worked with. In that area, there's not a lot of rocks that they were able to get, so we had to create a mortar mix with that. But then in other areas where there's an ocean nearby, there's coral rocks. And coral rocks then can be combined with the sand, then create a more traditional mix.
ARA's first-of-its-kind military construction package contains the first purpose-built software solution that converts 3D design files from CAD software into machine instructions for a 3D additive construction printer for the military. And with that information, the ACME Tech system can perform robotic concrete construction without the need for any form work.
It's a very robust solution that they can really beat up and that can get out in the field and be a really good workhorse without a lot of risk of it failing or not working correctly.
I had no previous experience really dealing with any of these types of equipment or machinery. So being able to actually learn what it's about and how to operate it and go through that process was pretty cool for me.
Being able to make a concrete mix pumpable is it's a tricky endeavor to make it both extrudable from the nozzle and being able to build multiple layers on top of each other without the whole structure collapsing.
We've brought some grad students and undergrad students with us from the University of Arkansas. They're all working on this research back home, and so this was a wonderful chance to get them out in the field and actually see some of what they've been doing in the lab. They get to work with soldiers. We're getting feedback from them.
The whole mixing process, the identification stuff, and then pumping, where it's all similar to what we already do. But the 3D portion of it, I think it's operating it on the tablet and seeing it print and seeing it, how you can control the flow of the pump and all that stuff. I think you then start to grasp the idea of it.
The soldier's input is invaluable, and we'll take that input back and we'll refine the technology.
When it's time to move to the next location, all components fold and pack up for a convenient trailering convoy. For more information about the ACME Tech construction system, go to ARA.com and search ACME Tech. For ARA, I'm Brian Goddin.